Hello everyone, welcome to my YouTube channel, Breaking Through Mathematics. My name is Evans Brezwamike and I'm very happy to have you guys here. So you're going to learn calculus and you're going to start with calculus 1, which is more of differentiation. But please do well to subscribe and also hit the notification bell so that you won't miss any new videos. Please also feel free to leave your questions in the comment section. I hope you're ready, so let's get started. So calculus is a branch of mathematics that deals with the rate of change. It is concerned with two basic operations, differentiation and integration, and it is a tool used by engineers to determine quantities such as rate of change and areas. In fact, calculus is the backbone for dealing with problems where variables changes with time. So let's also look at differentiation since we will dive much into differentiation. So we are saying in calculus, differentiation is one of the two important concepts apart from integration. So as I said earlier, we have differentiation and integration. So apart from integration, differentiation is one of the most two important concepts in calculus. Now, differentiation is a method of finding the derivative of a function. Differentiation is a process in maths where we find the instantaneous rate of change in function based on one of its variables. For example, it allows us to find the rate of change of velocity with respect to time, which is acceleration. It also allows us to find the rate of change of x with respect to y, which on the graph of y against x is the gradient of the curve. So here we mostly represent it by the y dx, and you will see such notation in no time. There are a number of simple rules which can be used to allow us to differentiate many functions easily. Yes, so there are many rules that we use to do differentiation, and we are going to start with one of the rules. That's the basic rule, right? One of the basic rules in calculus that we use to differentiate functions, and this is the differentiation from the first principle. Now, what's differentiation by first principle? So, differentiation by first principle is an algebraic technique for calculating the gradient function. The gradient between 2 points on a curve is found when the 2 points are brought closer together. The gradient of the gradient is given by the equation. Sorry, so the gradient is given by this equation. F prime of x is equal to the limit as h approaches 0. F of x plus h minus f of x all over h, where h is not equal to 0. So here we are saying h is not equal to 0 because if you make h to be 0, or if you let h to be 0, you're going to get undefined, right? Our function here, or our formula here is going to be undefined. Okay, so our function is going to be undefined. Now, in the formula of differentiation, or in the formula above, this f of x that we are seeing here is the function, and this function will be always given to you in the question that you'll be asked to find the derivative of that function, right? So, and f of x is always given to you. Now, f of x plus h is found by substituting x with x plus h in f of x, right? So if you are having f of x, right, to maybe this function, then what will be f of x plus h, right? So you just do substitution. You just substitute x with x plus h, okay? So that you get your f of x plus h, and h is the distance between the two given points. So this is the graph, right? So you can use this one to summarize everything. So you're going to um, derive this formula from this graph that you have here. So these are the 2 points you have in the graph, right? Yes. So as you know from um, our basic mathematics, when you draw a graph, you have something you call x1. That's the point. Yeah. So we have x1, y1, x2, y2, right? And here our x1 is x, y1 is f of x, x2 is x plus h, and y2 is f of x plus h. So we are going to find the gradients of these 2 points. And you know that the gradient is y2 minus y1 over x2 minus x1, right? And this is the formula. That's the formula of the gradient. So our y2 here and our y2 here is f of x plus h. Our y1 is f of x. Our x2 is x plus h, and our x1 is x. So if I do substitution, you see that I'll get f of x plus h minus f of x over x plus h minus x. But this x will cancel this x, leaving our h. Our h. So as I said earlier, this will cancel this because we're having positive and negative. So this simplifies our formula to f of x plus h minus f of x over h, and that is our first principle of differentiation. That's the formula, right? Good. So we then ask ourselves, how are we going to do the differentiation using the Abel's formula? Right. So what you're going to do is you're saying to do the differentiation by first principle. First of all, you have to find your f of x plus h by substituting x with x plus h in the f of x equation. Right. The second step is saying substitute f of x plus h and f of x into the first principle equation. Then you simplify the numerator, you divide all terms by h. Then finally, you just substitute h equal to 0 to develop the limit. Don't get confused, okay? We solve one example and you see that it's very easy. It's very easy. It's not difficult. It is very easy. So we have an example here which says find from the first principle of derivative. Find from the first principle of derivative of the curve y is equal to x squared. So you have to use the first principle to find the derivative of this function, right? Y is equal to x squared. Good. So what you're going to do is, first of all, you have to determine your f of x. And as I said, f of x is always given to you in the equation. So we are saying that let our f of x be equal to y, which is equal to x squared. So we are having our f of x to be what? X squared. Okay? And if you're having our f of x to be x squared, then what is f of x plus h? Right? What is f of x plus h? So our f of x plus h is where we substitute x plus h in place of this x here. Okay? In place of this x. Right? So our f of x plus h will be equal to, now we're saying f of x is equal to what? X squared. Then f of x plus h will be what? X plus h, or what? All square. Right? So we just substitute the x plus h here in place of this x here. Then if f of x is giving you this x square, right, then what will be f of x plus h? So our f of x plus h will be x plus h all square. Good. So we then do substitution in this formula. Right? That's our formula. So when you do the substitution, you see that so here will not be x, but it will be what? X squared, right? Because our function is x squared. So our f prime of x squared, please, this one is f prime. Yes, please, I forgot to say it. So if it's something like this, right? It is f prime of x. Yes, yes, it's f prime of x. You also have the dy dx there, but that one I won't say anything about it for now. You will see it in no time. Yes, so that's our f prime of x. So our f prime of x squared here is equal to, now the limit as h approaches 0, right? So we'll still maintain the limit of f of x plus h. Now we have our f of x plus h here to be what? X plus h all squared. So just put it there, right? Minus f of x, our f of x squared, right? All over h. Good. So when you come here, what you do is to expand this formula, right? So this function, you have to expand it. If you expand this function, you get x squared plus 2xh plus h squared. We normally say square the first, twice the product, and square the last, right? That's what we do. So after expanding this function, you get this from here to here. That is square the first, twice the product, and square the last, minus our x squared here, right? All over this h. Don't forget, we are still maintaining the limit. Now let's do some simplification here. So you can see that this x squared will cancel this x squared, leaving 2xh plus h squared all over h. So this place too, we can do some cancellation. We can cancel this h by this h, and also one of the h by this h, so it will be left with one h here, right? Good. So you're going to be left with 2x plus h, right? Yes, so 2x plus h. And don't forget, we are still maintaining our limit there. Now don't forget, it is at this point where you introduce your limit, like sorry, you evaluate your limit. So we are having 2x plus h, and we are saying h approaches 0. So just replace this h by 0, right? So you're going to get 2x plus 0, which is going to be 2x. And this is our final answer. This is our final answer. Yes, there's a shortcut way of solving this one. But in case that asks you to find um or find the derivative of this function using the first principle, you have to go through all these steps. Yes, yes. But there's a shortcut way for solving this, and I will do a video on that too. Yes, it's very short, very short. But now let's stick to this principle. You have a second question here which says find from the first principle of derivative of the curve y is equal to 4x cubed. So once again, this 4x cubed will be our f of x. Okay, so if f of x is 4x cubed, what will be f of x plus h? That is 4 multiply x plus h all cubed. Don't forget, we are replacing the x by x plus h, right? Yes, so that's how it will be. Now f prime of x squared, sorry, there's a mistake here, so it should be 4x cubed. So f prime of 4x cubed, right? F prime of 4x cubed is equal to, so by substitution, our f of x plus h is this, f of x is 4x cubed all over h, right? Our limit is also there. Now you have to expand this function, you have to expand it, x plus h all cube, right? You can easily use the Pascal's triangle to do it. Yeah. So here when you expand it, you get x cube plus 3x squared h plus 3h squared plus 8 cube. Yeah. Multiply your 4 minus your 4x cube here, right? That's your negative 4x cube. So you bring it here, right? And so when you use the Pascal triangle, whenever you expand a function exponent 3, the coefficient must be 331, right? 13, so it's 1331, yes, here. So the coefficient must be 1331. So you have a coefficient of 1, right? Coefficient of 3, 3, and 1, yes. And so that's how the Pascal's triangle says about this expansion. So you can learn much about the Pascal's triangle, and I will try my possible best if I can get a video of that too, to make learning very easy. Alright. So now when you multiply through by 4, you're going to get 4x cubed. You're going to get 4x cubed plus 4 times 3 is going to give you 12, right? So you're going to get 12x squared h plus 4 times this 3 to give you 12x h squared. Then 4 times this h will give you 4h cubed, right? Minus 4x cubed. Yes. Minus this 4x cubed. That's it. All over this h. And we are still maintaining our limits. So you can see that this 4x cubed can cancel this 4x cubed, right? And we'll be left with this expression, and that's it. Good. Now here too, we can still do our h cancellation. I can cancel this h with this h. Now this one of the h here with this h, and so it will be left one h here. Yes, one h here. Please, this one is h, okay? Yes, one h here. Then I'll cancel one of this h with this one too, so it will be left with h square. Yes, h square. H square. My 2 is zigzagging. Okay, h square. So it will be left with 12x square plus 12xh plus 4h square all over 1. So here will go to 1. Yes, so of course nothing will be left here, so it will be 1. Okay, so here will be 1. We now have this. So please, now here what you're going to do is you're going to apply our limit here. We are saying h is approaching 0. So whenever you see h, you just put 0 there. Okay, so it will be 12x squared plus 12x times 0, right? And 4 times 0 square. So this, you can choose to bring the square here. Yes, 0 square, and it is still 0. Okay, yes. So you can see that this one go to 0, this one go to 0, so it will be left with 12x squared, right? So bear in mind, whenever you differentiate 4x cubed, you get 12x squared, and whenever you differentiate x squared, you get 2x. Okay, so I have some few exercises for you. If I say trial, yes, and I'll be happy if you can try it and send me the solution. Yes, and if you have any question, feel free and um, send it in the comment section. So you have to find the derivative of these functions, right? That is y is equal to 3x, y is equal to 2, and y is equal to x. So this is the end of the video, and please do well to subscribe for me, and we'll continue this video in the next session. Thank you.